Section 8.4 is on testing a claim about a standard deviation or variance. And in order for us to claim something about a population standard deviation or population variance, we first have the requirement that we have a simple random sample and that the population is normally distributed. This is a very, very critical requirement for this. So the test statistic here is the chi-squared test statistic. It takes n-1 times the sample variance divided by the population variance. It rounds to 3 decimal point values, and it uses a degree of freedom of n-1. We obtain the p-value and the critical value from SAS. And a couple of important properties of the chi-squared distribution: all values of chi-squared are non-negative, and the distribution is not symmetric. It is specifically a skewed right distribution, as we can see in this picture down here. And there's a difference. There's a different different chi-squared distribution for each number of degrees of freedom. So 10, 20, and the higher that we go, it approximates the standard normal. So, for example, listed below are the heights and centimeters for the simple random sample of female supermodels: Lima, Bunchen, Ambrosio, Ebanks, Iman, Rubik, Korkova, Kerr, Kroes, Swanepoel, Prinsloo, Hosek, Klaas, Robinson, Heatherton, and Raffaelli. Use a 1% level of significance to test the claim that the supermodels have heights with a standard deviation that is less than the population standard deviation of sigma of 7.5 centimeters for the population of women. Does it appear that heights of supermodels vary less than the heights of women from the population? So here we have 178, 177, 176, 174, 175, 178, 175, 178, 178, 177, 180, 176, 180, 176, 180, 178, 180, and 176. We obtain this lovely normal quantile plot, which is pretty accurate for a normal distribution. So we have a simple random sample, and we have a normal distribution. Or I should say approximately normal distribution. So from this we have our null hypothesis that the standard deviation is equal to 7.5. The alternative, that the population standard deviation is less than 7.5. If the standard deviation is 7.5, the variance, when we square 7.5, we get 56.25, and the same for here. And if we toss this into SAS, we get a chi-squared value equal to 0.907, and the p-value is equal to 0.0001. And from the graph of this, this particular chi-squared value of 0.907, since 1 would be about here-ish, this would be about here-ish. And we are referring to this area below it, which again is why it's so low. But based upon this, we can write our conclusion of, at the 5% level of significance, since the p-value is very small, we could then say that there is sufficient evidence to support the claim that female supermodels have heights with a standard deviation that is less than 7.5 centimeters for the population of women. Thank you.